Welcome to Squirrel Trails. I'm David.
And I'm Al. Today we're actually going to start on an article I found, teaching kids how to programming. And it goes through 7 free programming languages to do it. And this is the start of the ongoing set of work that we're doing with Scratch Junior on teaching Abbigail, our daughter, David's daughter.
My daughter. Not ours, mine.
She's lived in my house for 4 years.
True.
To really teach her how to code. Scratch Junior is a great place to start, but we want to look at some of the other alternatives that you've got. And then, like I said, we're going to end it with going through one of the, and now I have to look, Coding Unplugged. The nice thing about the Scratch Junior program is it's got a card deck. You don't have to have it, but we're using it, this program right here, Scratch Coding Cards, as a way to breaking out and introducing the concepts for Scratch Junior. Because the first thing you want to be able to do is you need to learn some of the concepts of coding, but you got to make it fun.
Yep.
And that's what this will do. And we'll be intermixing the cards that we use within the actual coding cards, and then cards that actually introduce how to use the Scratch Junior playground or the Scratch box that you're doing there.
And there'll be a separate kind of grouping for all these videos that you can go look up for all the kids coding in it. We're actually calling it, Abbi actually named it.
Oh, she did.
Abbi's Coding Club.
That's good. I like that.
Go look for the folder there, and we'll do it. That you can kind of watch all the videos stack up there. You can watch one by one. And
given that Abbi has like no patience, we'll probably be burning through some of these things pretty quickly.
For sure. So yeah. So go ahead and let's start talking about these 7 programs.
Okay. I'll just start with, I pulled this off of Livewire, recent article that they put out. It's entitled 7 Free Programming Languages to Teach Kids How to Code. I really liked it. It runs through some ones that are pretty popular. It ends one that actually goes all the way back to one that I taught David with. Just more than a few years ago.
Yeah, a little longer than that.
So it was about Abby's age now that I think about it. So so there's this kind of stuff's been around for a long time, but let's go through what these are.
For sure. So okay.
The first programming language that is referenced in this article is Scratch. And that makes sense. It's done by MIT. It probably has the most push behind it. It's being taught in high schools and elementary schools all around the country. Lots of stuff out there on Scratch. The article goes through it on some of the basics with it. The thing I like about it, and they do as well, is that it's got a block storytelling style, which means you do everything with some fairly tangible blocks, and then you're able to put together, and just like building a building, you build code with blocks. It's really nice. And because it's done by MIT, it's got a lot of passion behind it. They are a leader in this area, and more importantly, it's free, which as all of these are. A couple of things that the evaluator said he didn't like about it, and I would agree with him again on these, is the website's a bit cluttered. There's a lot of stuff on the website that's there, but that's because there's just a lot of things going on with that. The other aspect within this is, that because it is so popular, it's being used a lot. You have to be careful about the social networking aspects because people are sharing these programs a lot. And so the social network aspects are a problem. You really have to think about, depending upon the age of your child, how much of that social networking you want them to get into as they're exchanging this stuff. It's not just pen pals these days as you start doing this stuff. When you're writing programs and sharing them, there's a lot of things you have to think about with that. So I want to be careful about that with some of the kids. And that is going to be an issue with Scratch and many of these others that have very large support communities. The value of a large support community, though, is there's lots of projects for them to learn. And that is a good part about Scratch is there's always something for the children to learn, or for that matter, adults to learn. I know adults that have actually learned how to code using Scratch. All right, the number 2 one that they've got here is Blockly. Now, Blockly looks a lot like Scratch. In fact, it's Google's refinement of Scratch. It uses the same kind of interlocking building blocks that come together. The nice thing about these blocks, whether it be in Scratch or Blockly, is if blocks don't fit together, you can't connect them. So if the commands won't work correctly one after the other, the blocks prevent the coder from doing something that would be a problem. So that's a nice way to help them not have a lot of coding errors when they get started. Now the challenge with this one is it doesn't have a lot of functionality to it, but what it does do is it actually takes the blocks that are built and translates it into a coding language. Now the one that's referenced on the screen is JavaScript, and that's kind of cool because you can actually then, if you're interested and your child's old enough, they can build the code in Blockly, fairly simple, and then you could actually walk them through the code that is converted based on those block commands. That's a nice little refinement as you're trying to convert from kind of these self-help little code programs that you've got with these teach yourself to code routines, and then actually converting them into a language. So it is kind of nice to be able to do that conversion. So with the software actually converting the basic block commands that you did in Blockly into an actual language, you can see how these things flow together. And that's a really good way to learn as the kids get older. Bit of a challenge here. It is supported by Google, and they've kind of stopped doing anything with it. MIT is looking over the fact that the term used in the article is they abandoned it. It kind of boggles my mind. So MIT is now taking it over because it does look so much like Scratch. So potentially we may see some really good things with this, or something that Scratch has, something Scratch-like, that uses that same conversion. It is for older kids. It's designed for people 10 and up, whereas Scratch is actually 8 to 16. So we'll see what happens with this one. The third one we're going to do is called Alice. Now, Alice is a 3D programming tool, which is kind of cool. Not just, as Scratch and Blockly tend to be very two-dimensional in their presentations. This one has some nice three-dimensional aspects to that. It has, it teaches really concepts of object-oriented programming. So it uses that concept of building blocks that we've been using to develop games with Scratch and Blockly or Scratch Junior, and then takes them up to another higher level. This was developed by Carnegie Mellon. It's not quite as slick looking as Scratch, but it is there. It does have a very straightforward design. Doesn't have the same block structures, more like a fill in the blank with the sentences. It does try to push more to a pure coding concept. In other words, actual coding lines of code as opposed to blocks. So if your child that's learning is younger, that may be a bit of a challenge. You might want to think about it. And entertainingly enough, it says here that about half of the About page defends the project name of Alice. I'm not quite sure why Alice got to be a problem, but evidently it is. And the age group for this is 10 plus. The fourth free programming language referenced here is Swift Playgrounds. And it's kind of different in that it uses the Swift programming language for one, so it makes sense because it's called Swift. And it just looks really fun. It's got a playground essentially, big three-dimensional image that you have to basically move your characters around. Lots of conditional languages within, conditional phrases within this. So lots of things to see and do with this. It is because of the structure with very colorful, really colorful material on this and little challenges that are there, it really gets the student to dig into this thing and have fun, because after all, having fun is how people learn. Dry and boring doesn't really work from a teaching perspective. even though that's kind of what I do sometimes. But it is this is a lot of fun and outstanding. The use of color is just simply amazing as you go through this. It makes it look more like a game than anything else. So that makes it fun. It was developed by Apple. One of the challenges with it is that, one, it only runs on iPad. So if you're using the Kindle Fire like I do, it's not going to run on it. So, and it's very locked into the Apple environment. But welcome to the world of Apple. So the fifth one we've got here is called Twine. Nice thing about children that are interested in creating games, but don't want to deal with the technical aspects. And so it focuses on really building chaining ideas together. So very much like the block routines, but in this, it builds essentially blocks that are tied together with twine for all intents and purposes. The things we like about it is it really the focus is on how you chain ideas together. So it's a good learning process rather than actually building a computer program. So that's actually a really solid thing, is just because learning how to think is that first part of that. Downsides on this one, it is developed by a volunteer community. That's not a bad thing, but it is a concern for support. And as such, its website's a bit antiquated, so it's going to be a little hard to use. It is suggested for kids 12 and up that are strong readers. So that means that David's never going to use this. All right, the sixth one that we've got here is Lego Mindstorms EV3. Lego Mindstorms has been around for a while. It's I remember getting this for David when he was much, much younger. And this was just a lot of robotics. It was in the early stages of being able to do robotics and doing some basic programming. And it's great to see that it's still out there. It is focused on robotics, so coding is there, but it's you get to engage a lot of physical aspects with being able to do that.
With this one, it's, as I remember, it's not necessarily just moving forward and watching something happen, but it's also moving forward and then having an arm reach out and then open and close. So it's much more integrated with multiple things happening at once instead of just a 1, 2, 3, 4, 5.
Yeah.
Yeah, and it also you building stuff too.
Yeah,
physical stuff.
Yeah, the downside with this one is, yeah, we say that the programming language is free. That would be true. However, you need to have access to a Lego Mindstorms kit to have it available to run. So that's going to be a challenge. So you don't actually have to buy one. Some schools and libraries may have it available. You can maybe get it used someplace. I've seen them at a variety of thrift shops. So keep your eye out. I mean, eBay is your friend occasionally.
The one I had was an R2D2.
So yeah, that would be show how old it is. But yeah, it's a great way to learn the use of building blocks together. Clearly, with the Lego reputation, that's going to be around. It's not going to go away. And the fun part with this is a natural transition to robotics. All right, number 7 is Cotto. With Cotto, you're learning to program while you're building a gaming device. It's kind of fun. It is a game programming app from Microsoft that designed for Windows and runs on Xbox 360. So the Windows version is free. However, if you're going to run it on 360, you got to pay for it. The kids use the app to basically explore around and design games within a 3D world. So again, it's stretching their imagination, which is cool, and they like to have games. Lots of graphics interfaces with this, because obviously, since it's a game. The things that are really good about it that they reference here is it's got a very easy to use interface, which is great with kids. And they get to learn programming while they're using a gaming device. So they're all naturally using gaming devices these days. It does rely on some older hardware. The project itself is probably not, is defunct according to the author, so it may not be around a while. Nor does it actually really teach as much of the programming as you might like. So both Scratch and Blockly and Scratch Junior all build games as well. So those might be better alternatives for you. The ages here are 8 to 14. All right, so that's our 7 programming languages that we went through. Starts with Scratch. Now you'll reference that, you'll note that they didn't include Scratch Junior with that, and we're using Scratch Junior. Part of the reason is Scratch Junior is set for ages 5 to 7. So you can really get kids pretty young into these environments to teach these things. You want to be careful it's appropriate, that because it's just not age, it's the social conditions of your child and their mental ability and knowledge, because they're going to be a little bit of writing as they start doing some of these exercises.
Yep. And as we can tell with my daughter already, we're going to burn through the Scratch Junior pretty quick.
So that's actually kind of fun. So again, she's 7, so she's right at that upper age. So as you go through these, pick your languages. Pick one you want. We again are going to start with Scratch Junior and then probably directly go to Scratch with a sidestep in there with a couple of Harry Potter things that are attached to the Scratch routines as well.
Shh, don't tell her it's a birthday gift.
Shh. So at any rate, and her birthday's pretty quick, so we may be okay.
Yeah.
Key part out of this, though, is remember, whatever routine you decide to select and use, make sure it's going to be around for a little bit of time, because they're going to get into this and stay into it, and you want to make sure there's enough of a community to provide support, and look at some support areas within your communities. For girls Got Code is out there. There's an hour of coding. There are many, many different programs out there to get kids involved with this. Technology is just a thing that we do these days compared to, well, when I was growing up. Okay, yeah, there wasn't technology. So now we'd have a lot of it, so we want to get involved.
So with that, stay tuned to watch the video afterwards, and I hope you enjoy.
Take care, folks.
Welcome to Squirrel Trails. I'm David.
I'm Abby.
Today, we're going to be doing a little instruction for Scratch Junior. This is one of our first videos that we're going to do before we actually get into the coding side of things, kind of dragging, dropping code. So this is kind of a learning steps. Kind of, you go to do this, to do this, to do this, right?
Yeah.
So Abby, what will we be learning?
A program is a list of instructions that tells a computer what to do. A sequence or an order of your instruction matters.
Matters? Very nice. So, for a program to run, it has to run A, B, C, D, right? You can't go from A to Z, can you? You gotta give it steps, right?
Yeah.
Okay. So on the back, what do we have here? So, get ready.
You'll need a partner to play this game. What would be the best to move your friend from one place to another? Write your ideas.
Okay. So we're gonna take a little break here. We're gonna write down some ideas on how to get from one place to another. All right. So now we got the whiteboard here,
Okay.
right? What should I do? So you're gonna have you do something. What should I do?
You should walk here
Okay.
from go to Grandpa.
So Grandpa's on the other side of the camera, right?
Yeah.
Okay. So we're gonna write down. How do you think right now? Just kind of out of your head. How should we do that?
First, you should
Number one.
stand and
So first part is to stand up. Okay.
you should stand up right now.
Well, after you have it all written down, then we'll go do the motions. Okay.
Okay.
So we gotta plan ahead, right?
Second,
So step 2.
you should walk let's see, K.
Okay. No,
No.
she spells better than you do.
What's it?
W-A-L-K.
Okay. Okay. Yeah. Walk.
10. I'll do numbers.
Okay, so 10, yep. 10. Okay, 10 steps.
The third one.
So get from here to there, 10 steps. Now what?
Now turn number 3.
Okay.
You should, when you get to the wall, you should turn right.
Okay. Oh, well, I'll try it again. Here. Yep.
You erased all
I
of
know.
it.
Turn. Turn. Oh, good job getting the spacing.
I
R-I. G.
I know that. Turn right.
Okay.
And then you should do it all the way to the plug.
Okay.
Number 4.
Yes. So how many steps do you think to get to the plug?
Like 5 or 6 or
Okay.
7.
Let's go with 6.
4.
So walk 6 steps.
Walk.
There you go. Good job. Okay. I
Hey.
know. We don't need that letter. Okay. So once we walk to the plug, 6 steps. Then we do.
Then you should turn to this chair.
So what direction is that? Left or right?
Right.
Okay. So
I'm
5.
not gonna write the number because you already know the number.
Okay. Okay.
And I'm just gonna put right.
Okay. So to the right. Okay. And we don't need numbers because it's just our idea board, right?
Yeah.
Okay.
You erase the numbers.
Sure, I'll erase numbers. We don't go. Okay. So we're good to go, right? So should we try?
No.
Should we try? Oh, we're not there yet. Okay.
The 6th.
We don't need numbers.
I'm just saying it that
Okay,
I can
okay.
remember.
Yep. You
The
go.
6th one is go around the chair.
Okay.
So good. Turn left.
Okay.
Left. Left.
Okay.
Then right again.
Okay.
There's a lot of right.
Yeah. And left, right.
And Grandpa, don't move.
Because if he moves, then we gotta do more steps, right? Yeah. Are we good? Okay.
No, I just have to brush my hair.
Oh, okay.
May need a
You know what?
to do this more often.
Yeah. We'll get a hairband next time, right? Okay. So now we turn right again. And now we do.
Then right again.
Okay. Are we turning right so many times? Do we need to? Do we need to? Yeah. Okay.
She's gonna make you dizzy.
Then 5 more steps.
Okay, so we just keep right over here. Yep.
Just maybe 4.
Okay, 4 steps. Okay. 4 steps.
Good.
Okay. So now let's put our instructions to work.
Okay.
So I'm gonna sit down and you're gonna follow. Tell me what to do. What the
Grandpa.
Abby, now that we got everything written down, so what are the steps that we've created? So what are the instructions?
First you stand up,
Okay, so stand up.
then walk 10 steps.
Walk 10 steps. Uh-oh. I can't walk 10 steps. Do we make a mistake? It's okay. So we'll erase that part, right?
No, we can make it.
Oh, we can put, well, we'll just erase it, okay? So we accidentally wrote some wrong code.
Just put it right here, that way we can remember.
Okay, yep, okay. So let's start again. Okay, ready?
I have to write it down.
So, yep, well, we have, let's try, so let's say, we'll just go from that one to that one, okay? So what's next? So, we're starting beginning, right? Okay. So what do we do?
First you stand up,
Stand up.
then turn right.
Turn right. Uh-oh.
Again.
Ah. Okay. Again.
Erase everything.
Well, we'll just turn. Well, what direction should I turn?
Left.
Left? Okay. Okay, so let's try it again, right? Okay, so
First, you should stand up,
stand up,
then turn left,
turn left.
then walk 6 steps.
1, 2, 3, 4, 5, 6. Okay?
Then
What does it say?
turn right,
Turn right, okay?
left, right, right, right. No, that means wrong.
That's left. Now walk in 4 steps.
Then
1, 2, 3,
No.
4.
no.
Okay, so we gotta.
Yeah,
Okay.
But stand up. That's
Okay.
correct.
Yeah, so we gotta stand up. We gotta turn left.
No, we don't. We just. That doesn't matter because we
Oh,
messed up.
we needed that, right? So we
Needed that, but.
so stand up here, right? So turn.
Left.
Okay. All right. So
I want this to be more comfortable.
well, we're not using this. We're using the mic on the camera. Okay. All right. So we got this one was right. This one was right. Okay. And
Ooh.
L E F. Okay. Okay, good.
No.
It's fine. We don't.
Now you know how I felt when you were younger.
Because then it looked more like a T.
Okay.
Very good. She's learning how to write. She can teach you later.
Because I'm a very good teacher.
Okay. So we got stand up, turn left. Then we do walk the 6 steps, right?
No.
So what happens after we turn left?
Walk 10 steps.
10 steps can be too far. Remember, 6 steps got me there, right?
Yeah, but maybe 7.
We'll stay with 6, okay?
Okay, but put that there.
Okay, so next step is the walk.
6 steps.
Okay.
Then you should walk to the.
So I'm facing that direction. What do I have to do?
Turn left. No, right.
Turn right or left?
Right.
Okay. So I turn right, and then what do I do? So that's right. That's right. So turn right. So now I'm facing that direction. Now what do I do?
Then you should take like 8 steps.
Okay. So walk
8.
8 steps. Okay. Then we're good to go?
No.
No? Okay.
Then you should walk to left,
To turn left.
right.
Turn right.
This is harder than it looks, isn't it, Abby?
Yeah.
Okay. So,
That's why I'm nervous.
okay, so we turn right, right?
Then take 2 or 3 steps. Just do 3.
Okay. We can't add variables. Or loops.
Not yet.
That isn't the correct number. It's K.
I forgot the line, okay? I was getting there. So 3 steps.
Dad, I'll show you how to write it at 3.
I'm right now we're writing numbers wrong. This is why I type and don't write out. Okay. Okay, so I walk 3 steps.
Then you have to turn.
Should we just push the chair? Should we just push the chair away?
No.
Okay.
Then it would be too easy.
Okay. What's making it harder? So turn.
Left.
Okay. Are you sure we're gonna turn left? So we're
Yeah.
facing.
Okay, I'll
this-
show you. I'll show you.
Okay.
Okay, when you get over here, you say, which way to go?
So you turn right or left?
Left. Then you walk.
That way? Or would it be easier if we walked, turned to right?
No.
Right? Actually, you were right. So from here, we turn left, which is this way.
No.
Yeah,
No, this way.
that's right. Right hand, left hand, right? So we turn left.
No, that isn't the way. This is.
Why we turn this way?
Yeah.
Why?
It's her code. Let her do her code.
Okay. We'll turn right.
Left.
Turn left. So turn left, okay?
Because I have to make mistakes there.
Okay, yes, mistakes are good, aren't they?
Yeah.
Okay, so we turn left, yep. Now what?
Then you should turn right.
Okay, well, do we have to take steps first? How many steps should we take? 1?
3.
1?
One big step.
1 big step. So, one big step. 1 big. Okay, so we're gonna.
Dad, you have to read right.
I can't just write over what I wrote.
No, because I did that in school once.
And then you got-
And you wrote the I one. Let me show you. Like this.
Okay.
And you did it for the same one.
Okay, not a big enough line. Okay, so because we're running out of room, you're just gonna tell me how to do it, okay? Okay, so let's start. Here we go. Ready?
First, you stand up.
Okay, I stand up.
Then turn left.
Turn left.
Walk 6 steps.
1, 2, 3, 4, 5, 6.
Turn right.
Turn right.
Walk 8 steps.
8 steps. 1, 2, 3, 4, 5, 6, 7, 8. Okay.
Turn right.
Turn right.
Walk 3 steps.
1, 2, 3.
Turn left.
Turn left.
Walk 1 big step.
1 big step. Okay.
Turn around.
Turn around. Okay.
Walk 3 more steps.
1, 2, 3.
I'm a 2.
2. 2 steps.
Then turn left.
Okay.
Walk one big step.
One big step.
Yeah, move the stool away.
So to do that, we must push our hands up,
Yeah.
we grab, we pick up, and move this direction.
Again.
And then we do the same thing. So we do a loop. So we pick this up, turn left, or turn right, and put down, right? So we run the loop once.
Then, when you get to the end of the chair,
What was it?
when you get to the end,
Okay, that's a loop.
you have to take one more step.
So once we get to the end of the loop, we take one big step.
No,
Look at that.
one step.
One step, okay, one small step. Okay.
Then turn right, left,
Turn left.
and take 3 steps.
1, 2, 3.
Then you have short feet.
Okay.
Then now.
That's good, Buggy. Okay.
Then turn.
Do what?
Then turn right.
Okay.
Then take 5 steps. 5 big steps.
1, 2, 3, 4, 5. Okay, good job.
Then hug Grandpa.
Okay. Good job. High five, Abby. You did a good job.
I did make it.
Okay. So let's reset up. So Abby, what do you think about doing this step-by-step stuff?
It was really, really fun.
Yeah. What was something difficult that you found about doing all this kind of stuff?
Getting everything wrong.
That was difficult. That was tough. Yeah. But sometimes getting stuff wrong is kind of how you learn, right?
Yeah.
Okay. What did you like
I really liked it when it got finished.
when you got finished? So when I made it all the way to the end.
Yeah.
Okay. So with that, yeah. So go ahead and try this at home. It's pretty fun, pretty simple, and if you want, you can take it outside and do a really long, going from this side of the yard to the other side of the yard. Wouldn't that be fun?
Yeah.
Okay.
Let's try it, Dad.
Should we try it? Okay, we'll try it. We'll try it later. Okay. So with that, thank you for watching.
And don't forget to subscribe and like.